Hello, so in this video I'm going to talk to you about the modulus symbol starting to appear in equations and inequalities. I'm not going to get through in this video all of the more challenging types of question. This is really just an introduction to make sure you've understood at heart what's going on. I would suggest after you've got your head around the ideas in this video, it would then be time to focus on graphing them, because graphs are a really useful tool when we deal with more difficult solving with modulus. So this is just an introduction, and they're going to go away, talk about graphs in next videos, and then there will be other videos later on which talk through how to do solving with it. So the first example I've got for us here is the modulus of W is 6. Okay, and I've got myself a number line here. Now, if you remember, the way I suggested we think about the modulus is distance from 0. So what I'm being told here is the distance of W from 0 is exactly 6. And to help us think about this, I have a stick. Okay, so it's not very technologically advanced, but I've made this stick exactly 6 units long. So if we look at that distance there from 0 to 6 or to minus 6, it's exactly 6 along. And what I'm being told here is the distance from 0 to W has to be exactly 6, which is why I'm using a stick, because it's got a rigid set length. So if we look at this, W could be 6, because the distance from 0 up to 6 is exactly 6. So W could be 6. However, that's only one solution. If you think about it the other way, okay, if I put 0 at that end, I could also have negative 6. Okay, so W could also be negative 6 as well. And feel free to use the plus minus notation that you've seen before when you're solving quadratics and things, okay, if you're happy doing that. Next one, the modulus of x plus 8 equals 15. The first thing I'm going to do is get rid of the plus 8, just like we'd probably be tempted to do from our knowledge of linear equations. I'm going to subtract 8 from both sides. Modulus of x is 7. Okay, now I could again think about it on a number line, or we can think, right, the modulus of x has to come out of 7. There's two things I can put in here and then use the modulus to get 7. The first is if I just put 7 in, or I can put in minus 7. Okay, because if I put negative 7 in there, the modulus is going to make that positive as well. Okay, next one, a little bit more complicated. Okay, y minus 3 here, modulus has to come out 20. So we need to think carefully about what numbers we can put in for y that's then going to go through this sum and end out at 20. I'm going to think about what I could get inside here. If y minus 3 came out as positive 20 straight away, then I've definitely got there. Because if this is 20, modulus of 20 is 20. But I can also have it coming out as negative 20. Because if this bit here comes out as negative 20, when I then do the modulus to it, it comes out positive. So I can make y minus 3 20, and I can also make y minus 3 negative 20. I would not encourage you to do this using the plus minus symbol, because when people do that, they don't think about adding 3 to 20 and adding 3 to negative 20 correctly often. And I'll show you why in a moment. If I add 3 to this one, I'm going to get y is 23. If I add 3 to this one, I'm adding 3 to negative 20, which is negative 17. People who write them together with the plus minus often go wrong, because they'll add the 3 and then put minus 23 rather than minus 17. So that's something to be a little bit careful of. Next one, modulus of z is equal to negative 1. Now, what this is actually claiming is impossible. What this is claiming is the distance of z from 0 is a negative. A distance cannot be negative. So if you think about that, you're going to end up with no solutions. This is an example of how you need to keep thinking when you're doing the modulus. What you cannot do is write z is minus 1, z equals 1, and then solve, because you're not going to actually be capturing something that's sensible, that makes sense. So always bring it back to the reasoning underlying what's going on. I'm going to leave you a minute or two to do a few questions, and I'll talk through the solutions in a moment. Okay, so here's 7 questions in increasing difficulty on solving the modulus function. Okay, so for the first one, modulus A is 5, so A could be 5 or A could be minus 5. Apologies on this, by the way. Normally I would, of course, work vertically downwards, but because of the space I've got, I might have to work across the page, which I wouldn't normally do, but I'm just doing it so you can see everything in one place. Next one, modulus of b minus 3 is -1. I'm going to add 3 to both sides first of all to get modulus of b equals 2. This is painful. I want to put it underneath, but I can't. So if the modulus of b is 2, b could be 2 or -2. Okay. Next one, again, I'm going to take the 8 first of all to get 2 lots of modulus of c equals 1. Divide by 2, modulus of c is a half. And then if the modulus of c is a half, c can be plus or minus a half. Okay. Next one, if d plus 4 with a modulus is 7, I can either get this bit in the middle being +7 or -7. So d plus 4 can be 7, in which case d is 3. Or d plus 4 can be -7, in which case d is, -11. Okay, next one, e plus 10 can be 3, or e plus 10 can be -3. So e can be -7, or e can be -13. Okay, if you're ever unsure, it's always worth just popping it back in and checking that it works. That's absolutely fine to do. Next one, 3f minus 1 could be 12, or 3f minus 1 could be -12. And then again, solving linear equations, then add the 1 to get 13 divided by 3. Add the 1 to get -11 divided by 3. Okay, final one, 5 minus 2g modulus is 4. So 5 minus 2g can be 4, or 5 minus 2g can be -4. So 5 can be 4 plus 2g, 1 is 2g, half is g. And for this one, so I'll put it all together, or 4.5 is my possible g value. Okay, so there are some examples of equations with the modulus function in, a few simple ones. I'm now going to introduce you to the idea of an inequality coming in. Okay, again, just some basic ones for the moment. Okay. Oops. Here we go. Okay, so this time I'm telling you that the modulus of x has to be smaller than or equal to 5. So again, I would encourage you to think about this in distance. The distance of x from 0 is less than or equal to 5. And to demonstrate this one, I don't know how well it's going to work. I've got a piece of string. Okay, so here is a number line with 0 on in the middle, and we've got -5 and 5. And what I'm saying is I can be anywhere on that number line as long as the distance from 0 is 5 or less. Now I've tried to make this string a distance of exactly 5, so we'll see if this works. Apologies if it doesn't. So basically this string can go to anywhere up to 5 away. That's the maximum, but it can be anywhere in between as well. Okay, and on this side again, it can be anywhere up to 5 away underneath. Okay, so it's because it's an inequality. I'm not using a stick this time. I'm using a string because it's all of the ones in between as well that I could go to as well. So if I wanted to draw that on the number line to make it a little bit clearer, I could say, well, I can go down to -5 or up to 5, and because I'm including them, because I can be equal to, I'm also going to follow them in. Hopefully this is notation that you're familiar with. Okay, and then I'm going to join them up to show that I'm capturing -5 and all the numbers in between all the way up to 5, including any decimals, any fractions, any irrational numbers like √2 that I might find along the way. Okay, so if the modulus of x is less than or equal to 5, I need to find a way of expressing all of these. Okay, another way of expressing that would be saying -5 is less than or equal to x is less than or equal to 5. Okay. If you've done general binomial theorem already, you will have seen mathematicians starting to use the modulus function to express an inequality like that. If you haven't, you've got that joy to come. Okay. Next one, the modulus of z has to be bigger than 4. So what we're saying here is the distance from 0 to z has to be more than 4. So if we think about a little sketch of our number line, okay, z can be further away from 0 than the 4, and it can also be further away from 0 than the -4. It's got to be further out there. Okay, I'm not including the 4 itself this time because I haven't got an equal symbol. So I'm going to do some non-coloured in circles to represent that. And to show that I could carry on going forever, because 100 is definitely more than 4 away from 0, I'm going to put a little arrow on here to show that they carry on forever. So now I can express that as 2 different inequalities. I can say that z is less than -4 or z is greater than 4, okay, to capture all of those possible z values that make this modulus inequality true. Okay, so hopefully you've followed along with all of that. I'm now going to ask you guys to have a go at some questions which are going the other way. So for these ones, I've given you a diagram and I'm asking you to come up with the inequality using a modulus to express what they are. And if you've done that, try and go from this notation where I've got a composite inequality or 2 inequalities to 1 inequality using the modulus function. Okay, if you manage all of those ones and you want a bit of a challenge, oops, let's just hold it there. See if you can express this inequality using modulus notation. Okay, so for these questions here, I'm going to pop 0 in so we can think about distances. So if I put 0 in here, we can see everywhere that I'm capturing is a distance of 3 or less from 0. So the modulus of x, if I'm using x, is less than or equal to 3. Here, if I put 0 in, I can see we're less than 1 away from 0 for all of the points that I need. So the modulus of x is less than 1. These ones here, if I put 0 in, we're noticing I'm further away from 0 than 2 or minus 2. So the modulus of x, the distance from x to 0, has to be bigger than 2. Okay, and this one here, similar idea, modulus of x has to be bigger than or equal to, because I'm colouring the circles, 19. Okay, now looking at these ones here, I'm capturing the values in between -6 and 6. So modulus of x is less than 6, and it's less than because I've not got the equals on here either. Okay, for this one here, I'm outside, so I'm further away from 0. So the modulus of y is greater than or equal to 3. And the final one, the modulus of z, because it's in between -2 and 2, has to be less than or equal to 2. Okay, closer to 0 than 2 each time. Okay, I'm now going to go through the challenge question. I'm going to try and explain it the way I think about it, but if you've got the right answer, a different way of thinking about it, that's absolutely fine as well. So looking at this here, I'm going to find the halfway point so I can talk about distance from a certain number. So between -1 and 5, we've got a gap of 6. So half that gap is going to be 3. And if I go 3 in from either of those numbers, I'm going to get to 2. So what I'm thinking of here as a description of the points that I'm capturing is anywhere that is 3 away from 2 or less. Okay, so a distance of 3 or less away from 2. Okay, problem is I tend to think about the modulus distance from 0, so that's why this is a challenge question as opposed to the pink ones earlier on. Okay, so let's think about this distance of 3 or less. X can be placed anywhere on my blue line. If I then want to think about the distance from 2 to x, I'm going to think about it as x minus 2. Hopefully you'll have seen that thinking when you did maybe distances on coordinate axes, circle graphs or something like that. But this gap here is going to be x minus 2. I'm deliberately doing it on this side. It will come out the same on this side, but just to make it easier for us to think about, that distance there is going to be x minus 2. I'm going to pop the modulus on it as well. Okay, so that represents, okay, that gap from 2 to the value that I'm thinking of. Okay, and I've said that that distance has to be 3 or less. Okay, so the modulus of x minus 2 has to be less than or equal to 3. And then just to check this, because this thinking is now a little bit more complicated, maybe a little bit less easy to think about in your head, let's test out the values. If I put -1 in, -1 take 3 comes out as -3, modulus of that is 3, that comes out true. If I put 5 in, 5 take away 2 is 3, modulus of that is 3, that comes out true as well. And if you want to test out any values along the way, you should find that they come out true as well.